Hello. In this demo, I'll walk you through how stakeholders and data teams can utilize Crunch to substantially reduce the time to insight and use Crunch AI for their exploratory data analysis, for root cause analysis, or maybe simple data extraction on a day-to-day basis. But before I dive deeper into a step-by-step walkthrough of the product UI, let me just give you an overview that how the entire product is structured. Crunch as a product has two major components. One is a semantic layer, which are your virtual definition layers, which contains the information that your different business metrics, where and how they are stored. And the other part is the operating layer, which works along with the LLM with in a to and from fashion to ensure that any question which you ask from the system, it gives you a precise answer to that. Diving deeper into the semantic layer, what we typically see is that our data is stored into different warehouses, but into a much more technically structured way, right? This is not something which is directly usable or consumable by the business teams, especially because the data requires some data preparation, the data requires extraction to a particular layout, and maybe the business metrics are not as it is stored inside the databases. So what Crunch allows you to do is that in Crunch semantic layer, you can define that, let's say, for a particular business team, it can be sales team, and a metric being pending issues, you can define that pending issues is something which you extract from your BigQuery database, from the table which consists of all the details of tickets, but where the filter or status is equal to pending. So in this similar way, you can have all these different metrics which are relevant for different teams and define whatever is essentially important for them. Diving deeper into the operating layer, this is the part where you as a stakeholder can come and ask any question to Crunch. What Crunch essentially does is that it shares that particular query with LLM, where it breaks down that for that particular query, which all relevant columns would be required based upon the semantic layer which you have created. It will write a SQL code and fetch it to operating layer to extract that information of that column from the different warehouses. So logic is defined out here, and what is to be extracted is defined by LLM for the operating layer. Operating layer gets that data, runs and execute the code out here, and present to you the final analysis. So this multiple to and fro which you would have to manually, if you were doing and running an LLM by yourself, is all streamlined by this AI agent which you have created by the name of operating layer. Let's try to run deeper into the product and see it working live here. So product. It is designed with the philosophy of keeping it super minimal but extremely powerful. What you see on the left is essentially three tabs. The first tab, consider this more like a data exploration tab, where you'll come on a daily basis to ask question or do analysis from your data. The second tab is semantic layer or the business definition layer. This is a one-time setup where the data teams define for the stakeholders or for themselves the different business definitions. The third part is fairly simple, where it just lists down the different data sources which are connected within the system. We'll start with the semantic layer. For this demonstration, I have created this demo semantic layer. This is a simple SQL Python notebook which data teams are very frequently and comfortably used to. What you see on the left hand side are the different data source connections. The data source can be a raw file which you can just upload into the system, or it can be like a database or warehouse connection. So all the prominent ones are supported out there. If you have any custom data source connection, you can request for that as well. Or output which is coming out of this notebook can also be used as a semantic view for any other semantic layer notebook. Now for this entire process, what I'm trying to do in this demonstration is that I want to create tables for my operations team, which contains all the information which is relevant to my operations team, which they want to get insight of, which they want to learn about, which they actually query the informations from. But also, I want to restrict any information which either is not relevant to the operations team or which should not be surfaced out to any particular team. So these are my two broader agendas. Step by step, what I've done out here is that first I've just went ahead and extracted a preview of all the information which is available in my database, and I created this particular table from the table of delivery details. But then I went ahead and also created this particular table where I have defined a metric of turnaround time, because this metric wasn't initially available in the way I have stored the data inside the database, right? For me, it is simply the delivery date minus order date, just for the demonstration, keeping it super simple. But the whole intent being that it can be any particular metric for your business teams. Operations team, it can be total turnaround time, inventory turnover, order fulfillment rate, warehouse utilization, and whatnot, right? If you are creating a table for finance team, it can be gross margin, inventory holding costs, profit margin, and so on. For marketing, it might be, let's say, CAC versus LTV ratio, or NPS score, and whatnot, right? So any metric which your stakeholder team is looking forward to, the data teams can define that out here and then create these tables essentially for that particular analysis to be done. I've done that and created multiple such tables, where in one particular table I have created and fetched all the details about the different products, which contains the brand, order, product ID, and so on. Other table is for the customers, so all the information relevant to customers and the demographics are stored in this table. Then there is a table for product details, which contains information about the price, brand details, product ID, product name, weight, and other such information. Then there is a table around the order details, which contains that when was the order placed, what was the order ID, which was the customer which placed that particular order, and what was the committed SLA, and so on. Once you mark a table as a semantic view, marking a table as a semantic view essentially means that now this table is ready for any stakeholder or for the data team itself to be used for further analysis, right? You can just see that particular table listed out here. So, and for example, if we dive deeper into any of these tables, you see the entire schema, so of the table which you just created. And here there's an optional step which you can do. So if a particular column within your table is not into a very well structured, or so if a particular column within your data table is not So, so if there is a particular column within your data table which is not clearly structured, like for example, you and me can understand S underscore P means selling price, but LLM might not be able to understand it that intuitively. So just go in a natural language, just define that what exactly do you mean by that column, right? So only for the columns which are confusing, it is a hygienic step which we recommend you to do. You just give a natural language description and add a business synonyms to that as well if required. And again, reminding you, this entire process is a one-time process where you just set it up for your different stakeholders, for your different teams, and define that from where the data is coming from and how a different business metric is defined in your organization. Once this definition is done, now on a day-to-day basis, or maybe hundreds of time on a single day, this is where the magic essentially starts to happen. So you can expose this entire view to your stakeholders, or maybe create a notebook for them by connecting the different semantic views. So a stakeholder, if they come onto the platform, they'll have access to only the semantic view which you have shared with them. If they have a particular question, let's say just relevant to customer, they can connect this customer details semantic view, or they can just go wild and connect all the different semantic views to this notebook, and essentially allowing LLM access of these particular schemas which we have created. You can just go and add a title, operations analysis, and if you want to create more sanity, there is an option to add text, SQL, Python code as well. But now let me just demonstrate the elephant in the room, the magic of crunch essentially. So there is this one question which I was exploring which just essentially talks about that, hey, my teams tells me that there has been delays in delivery dates for customers. Can you confirm that? And if that is true, tell me the number of customers for whom the order got delayed. A very, very simple question which any stakeholder might be having in the head, and there is no structure to which you have to write the questions across, right? So go as normal as you would be talking to an analyst. Just press enter, and what essentially now Crunch is doing. So remember the diagram where we were talking about the operations layer. This comes into the role player right now, where it is talking to the LLM and sharing this entire query with the LLM, where LLM will break it down first into different sections where it will try to identify that what particular column is required for this query to be answered across these different tables. And then it will write a SQL code that, hey, this is the exact operation you should be running on these tables to get the user the final answer. So this to and fro is happening between the LLM and the Crunch system to get you the exact answer. In a couple of minutes, you'll see the answer reflected out here. But if you want to dive deeper into it, if you want to understand what exactly the system is doing, just expand this. And here you can see a step-by-step process that what system is trying to achieve out here. Cool. Let me just quickly demonstrate what it is trying to do. It just says that identify the delivery delays by comparing actual TAT with committed SLA after joining relevant tables and tallying customers with at least one order exceeding SLA. Cool. It goes ahead and tries to identify if there is any null values. This is exactly what a typical analyst will do. Try to see that if the data sanity is present across or not. If you want to see the code, you can just click upon this code button, and here you'll see the exact SQL code with the LLM has written for you, right? Interesting. Then it goes ahead and says that the SC delivery performance table has no null in the key columns, and we'll check the SC order details for null values, checks again another table for the null values. And then it goes ahead and do this analysis where it's trying to understand the user plans to convert committed SLA and TAT fields to numeric types after confirming their format. So it is trying to have this particular comparison. You can see the code out here. What it is trying to do, it is trying to understand these two tables or table columns. Then it goes ahead and it tries to list down the text describes joining two tables to calculate the frequency of delays by comparing actual TAT with committed SLA agreements. It creates a particular table where it is combining now these two tables, which is SC order details with the delivery performances. So it wrote the entire comparing code by itself and created this table. And then finally, it just shows the count. The statement details a plan to identify the count of unique customers affected by the order delivery exceeding the SLA. And here it has given me the number of customers to whom the order got delayed. How beautiful is that, essentially? And it gives me this entire analysis. And for stakeholders, if they don't expand into it, in just a couple of minutes, here they see this entire result as the surface out to them that 13,219 customers were affected by that. So this was very, very straightforward and simple question where we asked the system to just understand, the basic data extraction that how many deliveries actually got delayed. But if you want to understand the correlation type of analysis, right? If that is what you're concerned about, then you can just go and type a question something like this: that hey, analyze the TAT performance across different warehouses and see if there's a correlation of some warehouses being responsible for TAT exceeding the SLA. So here I'll be doing this correlation analysis between different warehouses. Again, the same process where the system is trying to understand this particular query, trying to realize that which columns across your different semantic views will be required to give you the exact answer and do the step-by-step analysis with the LLM, right? So it is running this query. What I'll do is that I'll fast track this video for the next couple of minutes so that we just go and dive deeper into the final result. And finally, it gives the result where it says and the analysis of the TAT performance across different warehouses indicates that there is a variation in how the TAT exceeds the SLA. With some warehouses showing a higher percentage of orders with TAT exceeding the SLA, there seems to be evidence of correlation between certain warehouses and delivery delays. So one hunch which I had as a stakeholder is that maybe different warehouses are impacting it. It proves to be right because there are certain warehouses where the TAT exceeding the SLA is comparatively extremely higher. right? So here the entire analysis is done for me. So as a next question, let's just ask something which is across different other factors, that can you identify other factors across product categories, days, or the weeks, months, or customer segment which might be leading to delayed deliveries? So here I'm just trying to do RCA, where I'm trying to understand across different variables what might be impacting this. The same process is going to repeat again, where the LM is trying to understand this entire query, trying to map out the specific columns for this query, and create different SQL codes for me to give the analysis as what I'm seeking for. I'll fast track the video for you. All right, so here we come with the final answer, which says that considering the various factors for delivery delays, product category electronics shows the highest number of delays, days of the week, delivery performance is worse towards the end of the week, with Saturday having the highest delays. Months March have the significant number of delay orders, suggesting potential issue during this month. For customer demographics, more detailed analysis would be needed to conclusively identify trends, but initial data shows variations in delays across different ages, payment methods, and preferred product categories. So how beautiful is that? Where it is very deterministic, it gives you the exact answer that in product categories, days of the week, and months, these are the exact answers. But somewhere where it is not confident or not able to identify the exact analysis, it gives you the exact understanding of it. And if you want to dive deeper into it, again, you can ask the following question and get answer for the same. Similarly, what also you can do in Crunch is that any of the chart which AI generated for you, or any of the tables which AI generated for you can just go and plot different charts. So let's say I can just plot month over here, and let's say the total number of delayed order for each month. And I see that in the month of 3, I got the most number of orders. If I just want to plot the total orders across different months, so I see that in January, these many orders were 33,348. In February, I had 30,983. And in March, I had 33,447 orders. So any chart or any table which the AI has created for you, you can always plot a chart for that, share it across with the different stakeholders or within your team, and they can come directly and see this visualization which you have created for them. So in one place, you can do the entire RCA, you can create a report for your team, you can use AI to just get you the answer of detailed questions around your teams and your product in a couple of minutes. I hope this helps you understand the power of Crunch AI in your entire data analysis process. And well, if this is something which seems exciting to you and caters to your use cases, feel free to reach out to us at crunch.ai or message me on LinkedIn. We are super excited to have more and more use cases to be catered by Crunch. Thank you.